Welcome to the IAA Mobility Visionary Club podcast. Here we explore the intersection of technology, transportation, and sustainability. In this podcast, our host is an AI-generated voice, but the insights and perspectives shared by our guests are purely human. Each episode features two guests who bring their diverse professional backgrounds and personal experiences to the table. Today, we welcome Jessica Robinson, co-founder and partner of Assembly Ventures, and Mujeeb Ijaz, founder and CEO of Our Next Energy. Would you like to introduce yourselves briefly? Jessica, let's start with you.
Hey there. Well, you got it right. I'm co-founder and partner at Assembly Ventures. We're a early stage transatlantic mobility venture fund focused on the next generation of mobility technologies, which we describe as the physical and digital movement of people, goods, data, and energy. And Mujeeb is CEO of one of our portfolio companies, Our Next Energy.
Great to be with you. And Jessica, great to see you today. I am the founder and CEO of a new battery energy storage company located in Southeast Michigan. And we're working on transportation and stationary storage technologies that will help advance the electrification movement and help create this transition to electrification that everyone's going through right now.
Thank you. In this episode, our guests will share their knowledge and expertise on topics such as electrification, emissions and sustainability, business models and innovation, and the future of mobility. They will also provide personal anecdotes and insights that add a human touch to our discussions. Join us as we dive into the fascinating world of mobility and discover how it impacts our lives in ways we may have never imagined. Jessica, Mujeeb, we have prepared questions for you. Please take turns choosing questions. Would you like to start, Mujeeb?
Sure, I'm happy to. How about Future of Mobility Level 1?
What are the advantages and disadvantages of the concept of battery swapping at service stations, as an alternative to solely relying on integrated batteries?
I think the ultimate advantage is speed. People looking for a quick way to replenish energy is the obvious motivator for a swapping of a battery. I think that's the key advantage that is being proposed in business models. I think the disadvantage is the complexity of how many different types of batteries are going to be required in swapping stations if they were addressing a large segment of the population of road vehicles, meaning getting any two or three or more vehicles to agree on a standard where the exact same battery was being used across multiple platforms and multiple OEMs. That seems to me like probably the largest challenge. It's not insurmountable, but so far as I can tell, even with today's very strong ambition to design electric vehicles to be purpose-built around batteries, the batteries are still very different between one platform and the next across OEMs. So I would say that's the biggest barrier to the swapping idea to take root.
Yeah, Mujeeb, I think one of the areas where it could potentially work is for fleets where you have a large number of vehicles designed to similar specifications, right? So the operator knows which vehicles are where, which service routes they're running, and they control a few more of the variables that you talked about. And in a fleet environment, the uptime is super important. So if a vehicle can, run upwards of 60, 70, 80% of the day by using swapping some of the time, that could be another area that I think people will look at in the future.
Yeah, I agree with you. I think fleets are something that's more dedicated, controlled, and managed centrally. Makes a lot of sense. And maybe taxis are a good example of that. Large population city centers that are using taxi cabs that are on the road and running nearly around the clock, that kind of solution could make a lot of sense.
Yeah, good question.
Thank you. Please choose your next question.
Mujeeb, let's do business models and innovation level 1.
Great.
Many OEMs aim to establish a closed loop for their battery materials. What are the strategies, advantages, and disadvantages of implementing such closed-loop systems?
Wow. Okay. I'll start and then you should add some thoughts as well, Mujeeb. The obvious strategy, I think, is owning and controlling your supply chain. With our global supply chains as they are now, being able to have access to the materials, whether they're raw material inputs all the way through finished goods, on time and in the places you need them, obviously, is critical. But there are certain disadvantages too. The inputs of yesterday may not be the inputs of today. And so I think that's a really interesting consideration as we move through this electrified future. I'll let Mujeeb talk about this from the battery perspective. We've also worked with a company that works to recycle aluminum being a really important input for vehicles that are electrified because the weight of the vehicle is a really important determiner of the range of the vehicle. Aluminum lets that vehicle become lighter, so even when it has a battery, it can go further on a single charge. So Sortera Technologies minimizes the input of raw and primary aluminum. But how about for batteries? What do you see the challenges are there?
Yeah, I think if I were to point to the most successful battery recycling closed loop system, it's lead in lead acid batteries. And that system has taken, over 100 years to fully mature. But as of today, there's more recycled material going into new battery production than is virgin material. So that's a very successful closed loop system for producing an energy storage product, and one that we should take a hard look at. How did that arrive at its successful point of implementation? When I look at electric vehicle batteries, the problems that the batteries industry is facing right now is how to extract the material and get back to virgin material at a low enough cost that you're not actually spending more money doing that than you would be in mining new material. Meaning the recycled material should come onto the market as an advantage. To really close the loop, there should be an economic engine that propels it. And if there is not, then it's very difficult to get people to recycle if the virgin material is actually cheaper. What we've started seeing as an interesting alternative to thinking about closing the loop with battery as the starting and end point is that you might end up with a recycled material process where the end product in the recycling is used in a different industry. For example, an iron-based battery where you build it for lithium iron phosphate type of applications could then come back into the material supply chain to become a feedstock to steel as another way to close the loop with a robust industry that's not going to diminish anytime soon. So that's another way to close the loop, is not necessarily directly from battery to battery, but maybe from battery into another feedstock that then feeds a system that is very robust and large volume to take advantage of that. Some materials that are very expensive, like cobalt, definitely get recycled and go right back into battery. So the more expensive the material, the more likely it is that you can go right back to battery. The lower the cost material, which is good for cost and supply chain and developing the raw material supply chain, the less likely it is that you can make money in recycling it back into that same industry. So that's where the dichotomy is, and we're working our way through that.
Thank you. Please choose your next question.
Okay, I'll try. Let's try something like a supply chain level 3. I feel like we're in a game show, Jessica.
I know. Get ready for the hard ones.
You bet. Yeah.
Apart from geopolitical concerns, the mining of raw materials for EV batteries often occurs under environmentally and ethically critical conditions. What steps, strategies, and actions can the industry take towards a more sustainable and socially responsible supply chain?
I'll start and then I'll hand it to you. I think that we're entering an interesting phase of energy. We're going to be relying on different factors that have taken some time to start thinking through on how do we even get started. For example, the regulations around mining itself. Some countries are more prone to allow mining of raw material resources, and other countries have taken on regulations that limit the access to or the ability to mine, or at least it takes so long to get a permit that most industrial efforts shy away from one country versus another based on just the time it takes to get a permit. In that context, the battery world is a world in which we are headed towards mining and raw material selection as being kind of the root of it. Whereas the oil industry, oil and gas, has a predisposed set of conditions that most countries are now have worked their way through, battery material mining is a new topic. And as some countries are advanced by several decades of effort in battery material mining versus other countries, we see a pretty dramatic difference in how quickly we can get started on industrializing these mines. So I think taking a look at the advances by countries that are the most mature, China being one of them, and looking at what they've done to protect the environment and how they've addressed mining, permitting, and regulation standards, and seeing if those are applicable around the world and what, if any, gaps exist, might be a good way to get started.
Yeah, I'll add maybe something different that's not talked about as much, which is as those materials come into a domestic market, whether it's here in the US or Europe, I think we will see a shift in the ports of call and the movement of those materials once they're landside. And I wonder if there's an opportunity as we better understand that kind of next generation supply chain and, here in the US where those factories are located, to move those materials further inland. Freight rail being one of the most efficient ways that we can move raw material and making sure that the network is fully connected to take those materials that will be mined and processed under ideally better conditions over time, and then continuing a smart custodianship of those materials as they arrive and ultimately make their way to the factory. Then the flip side being true, you've got the finished batteries or the finished battery cells and getting them to the plants. I think there's a lot of opportunity for improvement in those systems. It will be complicated, but there is an opportunity to continue the kind of ethical or environmental look at the full battery supply chain.
Definitely. I agree with that. I'll just add one other thing, which is minimizing the waste streams and trying to figure out that when you're processing battery materials, that you should try to avoid creating third products that are very difficult to get rid of. That's actually at the heart of any battery processing design is what are the waste streams. And I think that we can, find a strategy where new regulations are compatible with minimizing these waste streams, and then getting into battery processing will be a lot easier.
Thank you. Please choose your next question.
Over to you, Jessica.
Yeah, I think it's me. Let's get to the heart of the issue. Let's do electrification for 100.
What tech solutions could address the common concern of limited EV range by improving range or significantly reducing charging time?
Mujeeb, you should start. This is your bread and butter.
Well, one of our projects within Our Next Energy is exactly to address advancing range in electric vehicle. And we took a long look at what is the right targeted range for a successful fleet adoption across all of the segments. And we think that we need to push up to around 600 miles of rated range on electric vehicle platforms like trucks and SUVs. And so what we've done to address that is we've taken the approach of a battery range extender as an augmentation to the primary battery. So an everyday electric vehicle battery would be made smaller, and then a much larger but more dense, more advanced chemistry would be brought in to do range extension, making the overall battery the same size, the same mass, and ultimately the same cost, but getting more range out of it. So that's what we're working on.
Yeah, and I don't think I'm going to give away too many trade secrets here, but Mujeeb, one of the things, as you know, that we really liked about Our Next Energy is the battery engineering itself includes software. And I don't know that that's always considered in this question of range, but these battery management systems that optimize the performance of the battery alongside the vehicle on any particular drive, but over the life of the battery are really interesting. There's obviously all sorts of applications of AI and learning over time. And it's an area that as an investor in the space, we get very excited about because it takes this hardware, right, the battery and its chemistry, but kind of brings it to the next level of its function in the vehicle.
Yeah, that's right. And putting software and AI machine learning to adapt the way the energy storage system delivers its range, performance, and improves its lifetime is a subject where when you have more than one chemistry, your degree of managing the trade-offs goes way up, and your ability to actually optimize how the energy is being delivered can advance when you take a look at the way the users are positioned and how they use the vehicle. For example, living in a flat environment that doesn't have any climate conditions versus living in a hilly country where you tow a lot, those types of algorithms would then self-optimize to deliver the best range performance. Exactly.
Thank you. Please choose your next question.
Okay, so it's back to me. Let's think about something that we haven't touched on. Emissions and sustainability. We'll go for level 2.
Are current battery designs durable and recyclable enough for endless usage? What are the most fragile components of batteries, and are there ways to enhance robustness and longevity?
Endless usage. Oh my goodness, that's like the never-ending gobstopper or something like that, Jessica. You want to tackle that first, and then I'll go next?
Oh, brother. I think you should go first.
All right.
You're the battery expert here.
I would say endless is a very, very long time, so I'm not going to ever go to endless. But what I will say is that battery technology needs to survive the 15-year in-service kind of benchmark. And one reason that we think 15 years makes a ton of sense for batteries as a life goal is that it creates a generational advance in itself every 15 years. So batteries, if you think about now 15 years into the future, will be at a high enough performance advantage that your goal is to move into the next product line. And so you would not want something that was 15 years ago. And if I look back 15 years from where we are right now, we were using nickel metal hydride batteries and even some platforms using lead acid. We would not necessarily want to say that battery should last endlessly. What we want is the right interval in which we can then move on to the next advances in technology that help us with range, safety, even better materials, better supply chain. And so I think that's the kind of targets that we're looking at. Yeah.
I would add, as I think about this question, the battery pack itself is designed to be, fully enclosed, self-contained, and survive, frankly, a very challenging environment, right? Which is the daily road vibrations of a vehicle. One of the areas that I don't know that the industry is fully settled on yet is serviceability of that battery pack, as some of those cells degrade or, maybe even fail over time. Should you be able to, pop the lid and service some of those cells, or do you use software to manage the full function of the battery pack to keep that in its vehicle on the road longer? Obviously, there's different opinions about each, but there are real engineering considerations, right? If you need to, quote unquote, pop the lid off, that's very different than, designing a structural pack that's welded shut and is designed to stay that way. And so that speaks to the, fragility of these battery packs once they're in operation, right?
Yeah, I think that's right. And as time has gone on, just look at consumer electronics. You used to be able to pull a battery out and swap it. And now the batteries are fully engaged and they're contained, and you can't really, you can't touch the battery of a smartphone. Also, the batteries are getting you through their emission profile of from morning to night, you can pretty much get through the day without needing to worry about recharging them. That's kind of where batteries are headed in mobility as well. As let's give consumers enough range, then let's make them sort of integrated and packaged in such a way that no one's really thinking about them. Then let's let them last, or create them in a way that they last long enough that the vehicle is being retired before the battery is really the reason that it's being retired. And in that context, I think 15-year life is something of a good goal.
Thank you. Please choose your next question.
I think it's me, Mujeeb. You ready to be brave? Should we tackle regulation level 3?
All right, sounds good. Regulation it is.
Considering Asia's dominance in battery technology, the initiatives taken by the EU and the US to establish their own production units, and the regionalization of battery supply chains due to investment programs, where do you foresee the epicenter of future battery development and production relocating to? What factors might contribute to this shift?
I can start with that one. I'm not convinced that we're going to have an epicenter. Our view at Assembly Ventures is that we will continue to see more regionalization. So you will have centers of excellence in production in Europe, as we will here in the US. I talked earlier about the integration of the supply chains and the inland shipping to support that. But we see centers emerging here in the US, Michigan, where I sit, being one of them. But there are, other areas that have historically been home to production of the automobile or truck itself. And we are seeing battery production move alongside that. Michigan, again, being an example. One of the reasons is transportation. These products and inputs are super heavy. And so if you can, co-produce and minimize that transportation back and forth, you're bringing efficiency to your supply chain. But frankly, also you're managing cost, but carbon input, which is, something we have to be mindful of in battery production. But Mujeeb, what's your perspective? You have, the challenge of figuring out where to put your plants.
Yeah, I think for sure the idea of an epicenter isn't good for the industry. I think it should be regionally diverse, and that we should find local supply chain where we're manufacturing the products for either transportation or stationary applications. That's kind of the point of selecting raw materials that don't require an epicenter approach, because any kind of approach like that, as you point out correctly, is going to require moving a massive amount of raw materials around the world. Sometimes you can travel 15 to 20,000 miles before you've reached your point of destination where the products are being made. I don't think that's the right approach. I think the right approach is to find the right raw material strategy that allows us to regionally manufacture, and that we avoid those long supply chains, which will then ultimately drive better cost and even improve workforce development local to the countries that are needing the products, where the manufacturing and the deployment take place in the same areas.
It's time for our last question. What are your expectations for the next IAA Mobility, and what are you looking forward to?
Oh, we are very excited about IAA Mobility. Assembly Ventures is partnering with the show to bring a whole day of programming to the Visionary Club stage. And Mujeeb, you'll be joining us there, I hear.
Yes.
But we're thrilled to come to Germany, the other home of Assembly Ventures, and continue discussions like the one we've had here today.
Yeah, I think that the format in which the questions go into many different facets of our industry, it's stimulating discussion. Also, it causes us as leaders to think about the problem differently, as we're getting questions on regulation, on business model, mobility, electrification. There's so many different topics. So I like the format, and I'm looking forward to the next time we join together. Thanks.
Powerful insights. That's all the time we have for today, unfortunately. Thank you so much for being here.
Thank you.
Good to be with you.
Thank you for listening to this episode of the IAA Mobility Visionary Club. In our next episode, Maria Tsavahidis, CEO of EIT Urban Mobility, and Professor Marco Tabermelstruit, Professor of Urban Mobility at the University of Amsterdam, will be speaking about smart cities and urban planning. Stay tuned. If you liked what you heard, please consider giving us a review. To stay up to date on all things IAA mobility, follow us on our social channels. They're linked in the description for you. The IAA Mobility Visionary Club podcast is produced in cooperation with our knowledge partner, the Boston Consulting Group. See you next episode.